According to recent Steam surveys, nearly 60% of users have a primary display resolution of 1920 by 1080. That's 1080p for short. And according to a smaller survey conducted on our own Twitter handle, @ScienceStudioYT by the way, nearly 60% of sampled users sit approximately 2 feet from their monitor or multi-monitor setup. We tend to gravitate toward an optimal viewing distance from our display of choice, right? So if we can see pixels, we back away, and if it's too difficult to see anything on screen, we move a little closer. No two monitors are alike, both in terms of size and resolution. So what resolution then is the best for gaming? And just a heads up, it's not a straightforward answer. I want to introduce you to this fancy little equation based on assumptions derived from the, quote, visual acuity threshold, a fancy phrase referencing how far away you have to be from something before you can no longer discern individual details. If we assume 1 arc minute to be the limit of detailed discernment for the human eye, from where we get things like the Snellen chart, which I'm sure most of you who wear glasses have seen before, then this equation will accurately calculate your optimal viewing distance. Now, it seems like a mouthful up front, but the variables represent a simple plug-and-chug format. VD here represents viewing distance, DS is your display's diagonal size, NHR and NVR are the display's native horizontal and vertical pixel counts, and CVR is the vertical resolution of the image displayed on screen, assuming you're upscaling or downscaling. That's what this accounts for. So there's really no complex math involved here, just division, multiplication, powers, square roots, that's it. So let's use the info we received from users earlier to calculate an optimal viewing distance. Given a resolution of 1080p and a common diagonal size of, let's say, 24 inches for a 1080p panel, we can swap these variables for real figures. VD equals 24 divided by the square root of 1920 divided by 1080 squared plus 1 times 1080 times the tangent of 1 over 60. And make sure if you do this equation in Excel that you incorporate the conversion between radians and degrees. So in this case, it comes out to approximately 37.5 inches. And what this tells us, given these parameters, is that you'll experience loss of detail when sitting further than this distance away from a 24-inch 1080p monitor displaying a 1080p image. If we replace the image on screen with something half as pixel dense in one dimension, that's 540p, then the max distance before detail loss jumps from 37 inches to roughly 75. And this makes sense, right? If you have the resolution of the image displayed, then you can double your viewing distance, accommodate for that loss, and lose no detail. That's what this equation basically tells us. It links resolution to viewing distance with respect to display size. Now, if we shrink the diagonal display to, let's say, 18 inches, right, much smaller, then the detail loss threshold shrinks from 34 to 28 inches. So display size and viewing distance are, of course, directly proportional because PPI changes as that diagonal space, right, tends to shrink or expand. And just one more example, if we bump the display resolution from 1080p to Ultra HD or non-cinema 4K, then the loss threshold shrinks to a mere 19 inches. 4K is a huge jump from 1080p, both in terms of actual PPI and overall hardware utilization, which is why most 4K monitors on the market are larger than 24 inches. So in this example, you have to sit within 19 inches of the 24-inch 4K panel to actually reap the benefits of a true high-intensity 4K image. Otherwise, it's going to look the same as, say, a 1080p panel. There are several complementing charts, by the way, linking the two. This one here attempts to quantify the relationship between viewing distance, panel size, and optimal resolution in a visual manner. By the way, do keep in mind that this calculator of sorts should only really be used to determine maximum viewing distance. You're likely to notice extra details on screen the closer you sit to the display, up to a certain point, of course. Then viewing angles becomes a huge factor in the fact that you can discern individual pixels. When you get too close, that means your resolution isn't high enough. This is also why curved monitors make more sense for gamers than casual TV viewers. You'd have to assume everyone watching the screen is sitting in the exact same place, which of course doesn't happen, not in a living room. So curved panels favor a single viewer, and while I'm not completely sold on them, I mean, this is kind of a separate topic, but I wouldn't pay a great deal of money extra for a curved panel. I do notice slight benefits, especially with ultra-wide resolutions like the one behind me here. This one is a 3440 by 1440p panel. So the best resolution for gaming depends entirely on your monitor size, its resolution, and your viewing distance from the monitor. This ignores, of course, refresh rate, which is an entirely separate topic, explained right here, by the way, and the necessary hardware needed to adequately drive these pixels. Again, totally separate topic. Now, if you ask me, 1440p is a great sweet spot for a decent gaming rig. I use the Asus 27-inch 1440p 165Hz monitor for my gaming rig, and the resolution is almost perfect considering how far away from the screen I usually sit. That's about 2 to 3 feet. I also prefer a higher refresh rate over a higher pixel count, so I would trade 4K for, 144Hz 1080p any day of the week. I can personally discern pixels on a 24-inch 1080p panel from about 2 feet away, but when I step up to 1440p in the same format, it's almost perfect. The goal is to minimize resolution as much as possible to alleviate stresses on your graphics card and CPU while maintaining the maximum level of visual detail possible without being able to discern individual pixels. That was a very long sentence and you may need to rewind it, but you'll find most of this to be, common sense, right? Save maybe the detail of the equation that we showed earlier. I've linked a few excellent monitors, by the way, in the video description. If you are in the market, I invite you to take a look and comment down below with your current visual setup. If you guys like this video, give it a thumbs up. You know what to do. Thumbs down for the opposite, or if you hate everything about life, you can click that red subscribe button if you haven't already, and stay tuned for more content like this. This is Science Studio. Thanks for learning with us. I get to breathe now. This is good.